Well, hello there to all of my friends in my 3C class. Oh, we're going to talk today about switching into standard form. Exciting stuff. Standard form is unbelievably exciting. So our goal today, I can expand and simplify expressions and change quadratic functions into standard form. Okay. Switching to standard form. Let's do a quick recap. This is stuff we did in the last unit about how to expand and simplify the following polynomials. Now, each of these stars over here just gives us the finer points of what we're going to do, but I'm going to go through these rather quickly. So, expand and simplify each of the following polynomials. Well, this is just FOIL or double distributive law. As it says over here, use double distributive law or FOIL to expand the brackets. So we're going to multiply the 2 through the brackets, and we get 6x squared, because that's 2 times 3, and then x times x is 6x squared. And now I do 2 times negative 7 is negative 14. And of course it needs that x there because there was the x there. Now I'm going to put the 5 through the brackets. That's going to give me plus 15x. And one more time, minus 35. And now I'm going to combine the middle terms because they have the same variable. They both have an x. So negative 14 and positive 15 go together to create plus 1x. And then, of course, we've got that minus 35 on the end. Now for this one here, I'm going to leave this 7 out front. Notice it says up here, first expand and simplify the brackets, then multiply the coefficient through. So I'm going to leave the 7 out front, and I'm going to expand the brackets. Now this isn't quite in the order that we're used to seeing it, but that's no problem. I'm going to still continue to do it in the order so that I don't miss anything. So p times 8 gives us 8p, and then p times negative p is negative p squared. Now we're going to put the 4 through. That's going to give me negative 32 is negative 4 times 8. And then negative 4 times negative p is positive 4p. So negative times a negative is a positive. Now I want to simplify what's in the brackets, and I'm going to make sure I write them in the right order. I'm going to put this p squared first. Usually we see the variable that's squared. Then we see just the plain variable. So that's 8p and 4p is plus 12p. And then we have the constant term on the end, minus 32. Lastly, I'm going to put that 7 through the brackets, negative 7p squared. 7 times 12 is 84, so plus 84p. And then 32 times 7, well, 30 times 7 is 210, and then 2 times 7 is 14, so that's going to be 224. And lastly, we need to remember what a square bracket means. It means that this is 5t minus 3 and 5t plus 3. Oops, sorry, not plus 3. What am I thinking? We need two of the same brackets. 5t minus 3, 5t minus 3. And now we're just going to multiply through like we did before. 5t times 5t is 25t squared. And then we do 5t times negative 3 is negative 15t. And negative 3 times 5t is negative 15t. And lastly, negative 3 times negative 3 is positive 9. Now we're going to simplify and put the middle two terms together. So we have 25t squared minus 30t plus 9. Now, there is our expansion and our quick recap. Took us just under 4 minutes. Now we're going to take a look at switching from factored form to standard form. Remember we talked about all the different forms before? We're going to do the hard stuff later, which is going from standard form into this factored form, but for right now we're just going to go switching from factored form to standard form. So this is factored form. So I want to write this in standard form. All I have to do is expand it. So I'm going to take this down here. Basically, I'm asking you to expand and simplify. The only difference between this and what we did up here in this particular question here, the only difference is that there's a y out front, and that when we're done, we're going to have a parabola that we could plug into a graphing calculator and actually see the nice parabola shape. So I'm going to leave the 4 out front, and I'm going to multiply the brackets out. X times x gives us x squared. X times 5 is plus 5x. 3 times x is plus 3x. and 3 times 5 is plus 15. We're going to simplify that up because I can put the 5x and the 3x together. So I have x squared plus 8x plus 15, and then 4x squared plus 32x, and then 4 times 15 is going to be 60 plus 60. And that's in standard form. This is the standard form. What do we know about standard form? Well, remember, the only thing standard form is actually good for is finding the y-intercept. And the y-intercept occurs when x is 0. So if x is 0, these two terms disappear completely, and the y-intercept is simply the constant term on the end. So once we've got it in standard form, I know the y-intercept. Now, let's have a look here. We're going to switch from vertex form to standard form. This one's a little bit tougher, but only tiny little bit tougher. Basically, what I'm asking you to do is expand and simplify the expression on the right-hand side. We're going to leave the y where it is, and we're going to expand and simplify this thing. Now, let's look at the steps that I've got marked over here. It says write the squared bracket as two brackets multiplied together. So we've got x minus 3 times x minus 3. And then we get the negative 7 on the end. Now we're going to multiply those brackets out. So x times x is x squared. And then x times negative 3 is negative 3x. Negative 3 times x is negative 3x. You may have noticed that these two middle terms are the same. That's no coincidence. Whenever you put these two brackets out, those two middle terms are always going to be the same. So anytime you have a squared bracket, when you expand it, you're going to get two middle terms that are exactly the same. That might give you a little bit of a shortcut. So we've expanded the two brackets. So check and check. What's the next one? Multiply the coefficient through the bracket. Well, I'm actually going to simplify first. There isn't a step for that, or it doesn't matter where you put it, but I'm going to simplify in the bracket first. Now we're going to multiply the coefficient through the bracket. So I'm going to go 4x squared minus 24x plus 36. And then that minus 7, of course, is still hanging around on the end. So check. And last, simplify and be sure it is in order of descending powers of x. Now that just means first x squared, then x, then the constant, which we've already kind of got that. We just need to simplify the constant on the end. So we're going to go 4x squared minus 24x, and then 36 minus 7 is plus 29. And now this is in standard form. What is standard form good for? Well, the only thing standard form is good for is the y-intercept. And so I now know that the y-intercept, which occurs when x is 0, so that these two terms go away if x is 0, 4 times 0 is 0, 24 times 0 is 0, so those go completely away. The x-intercept is 20, or y-intercept is 29. Okay. Now, this up here, vertex form, was much more useful. Remember, vertex form can tell us where the vertex is. This vertex is at 3, negative 7. It also tells us where the maximum or minimum value is, and it gives us a way of actually graphing it. Okay, but standard form gives us the y-intercept. Put the following parabolas in standard form. So here's our example. I would strongly suggest that you pause me right now and try this yourself. But I'm just going to plow through it. Remember, we're going to leave the 4 out front first, multiply these out. We get x squared plus 3x minus 6x minus 18. I'm going to simplify this in here, leaving the 4 out front. We're going to get x squared minus 3x minus 18. And then lastly, we're going to put the 4 through the brackets, which is going to give us 4x squared minus 12x, and then 4 times 18 is 64. And we're done. And what's the only useful thing that we have here? Well, it's this out here. This is the y-intercept, which is negative 64. Now this one here, when we expand it, this one is in vertex form already, so I know what the vertex is. What's the vertex? Yeah, I think I can hear you. Shout a little bit louder. A little bit louder now. A little bit louder now. Come on. 6, -8. I heard it. Yep, you shouted loud enough. Okay. 2 bracket. Now remember, I've got to write 2 of these out. That's what the squared means. It means I have an x minus 6 times an x minus 6. And then that -8 is just hanging around on the end. He's just floating there. He's just waiting for a chance to jump in a little later. So we're going to multiply those brackets out. I'm going to leave the 2 out front. Let's see how fast I can talk. I'm going to do x times x is going to give me x squared. And then x times -6 is -6x. And -6 times x is -6x. And -6 times -6 is positive 36. And I have the -8 on the end. Now remember what I said before, I want to combine the 2 middle terms. Let's see if I can still keep talking really fast. I'm going to go x squared, and the 2 middle terms are going to combine to 6x, and a 6x is 12x. And then we got plus 36. And we're going to subtract the 8 on the end. I'm going to put that 2 through the brackets. So when I put the 2 through the brackets, I get 2 times x squared is 2x squared. That's that there. Now I'm going to multiply that out. That gives me -24x. And then 2 times 36 is plus 72. And I got to subtract the 8 on the end because it's right here. And if we drop it, we are wrong, quite simply. So then I have 2x squared minus 24x. And then 72 minus 8 is plus a 64. What's the y-intercept? Come on, a little bit louder now. A little bit louder now. What's the y-intercept? The y-intercept is positive 64. Oh, isn't that a coinky-dink? We got -64 in this one and positive 64 in that one. Anyway, one more question. This one is a word problem. A study shows that 60,000 students will attend a play in 1 week if the ticket price is $40. For every $2.50 added to the price, 2,000 fewer students will decide that it's way, way, way too expensive, and they're not going no way, no how, not a zip, zilch, nothing. Okay, so what information do we have here? Right now, 6,000 students attend, and they each pay $40. Geesh, wonder how much money that is. 6,000 students, they're each paying $40. Well, that's, I need 24, and then I've got 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. That's 2 million. Got the spaces off here. $2,400,000 for that play. That's kind of amazing. For every $2.50 added to the price. So if I add one $2.50, then now I have 2,000 fewer going. If I add $5, that's adding this twice, I'm going to lose 4,000 students, and so on and so forth, and continue on. The amount of money in the theater will earn before expenses. This isn't profit. They have to pay the people in the play. It's called revenue. So revenue is the number of tickets sold times the cost per ticket. That's what we actually found out here. This was the revenue. This is their current revenue. We found out how much revenue they're taking in now. Now, out of that $2,400,000, they have to pay for the theater, they have to pay for props, they have to pay for the actors and everything and so forth. So it is not pure profit. Did you see that little thing? My volume just went down. I'm not sure that, I hope that didn't turn me down on you. Okay, so what is the revenue when tickets are $40? Hey, we just found that. We found that out there out of curiosity, not because anybody told us. So in this case, revenue equals the number of tickets sold. We have 60,000 students each buying a ticket, so that's 60,000 times $40 per ticket is $2,400,000. Now the revenue can be written as a function of n. We're not going to use x this time. We're going to use n, where n is the number of times we increase the price by $2.50. So this says that if I increase the price by $2.50 one time, then my price is now $42.50. So I just have to add those two because 2.5 times 1. But what if n is 2? If n is 2, now this becomes $5 and it's $45. Now I wouldn't be writing this because I'm just making a point here. What about if n were, say, 10? Well, if n were 10, that means that this now becomes 2.5 times 10, or $25, and that means that the total price per ticket is $65. Now, they're not going to get too many people coming if they're going to charge $65. That's a fairly big increase. Okay, but that's what this means. How was the equation found? Well, it was found by tacking on this 2,000 n is the number of students lost for each $2.50 increase. Okay, so every time I increase this by 1, this gets increased by 2,000. So we lose another 2,000 people. Okay, write the equation in standard form and use graphing technology. So I'm going to really quickly write this in standard form. We're going to expand this out. 60,000 times 40, we've already done that once. That's 2,400,000. And then I'm going to do 60,000 times 2.5n, which is going to give me plus 150,000 n. Then I have to do this one, which is going to give me minus 80,000 n, and then 2,000 n times 2.5 is going to give me minus 5,000 n squared. Now, this middle goes together, and I'm going to write it in descending powers of the variable. So negative 500,000 n squared plus 70,000 n and plus 2,400,000. Now, what is the y-intercept? Now, that's assuming that we call this y and this x. Okay, what's the y-intercept? Well, remember, this is going to go away, so here's our y-intercept. So this is the y-intercept. Now notice that this y-intercept is actually what we had up here if we don't increase it at all. Okay. Then it says graph using technology. What is the maximum revenue and what ticket price will it give? So I'm going to graph. I've already actually plugged this into a graphing calculator. We're going to do this fairly quickly. There it is. It's been plugged in, but it's not here. And it's not here because we have to zoom in a little bit. We have to move this around and find it because it's way gone out here. Remember, it's like 2 million. So I'm going to find it. Just give me a second. I'm going to put you on pause. Okay, here's what I did. I know I need to get up past 2,400,000 because that's where we're going. That's my y-intercept there. So when I clicked on this settings, I said my y-axis, I need it to go all the way up to 2,500,000. So what I actually did was I put in 3 million up here. And you'll notice that now I can actually see this. Now, so here, it's traveling along. We want to know where the top of that is. Well, I can't really see it, so I'm going to have to make my x's bigger. So I'm going to have the x's go to, let's have them go to 20. And look, we can find where the top of it is. And in this calculator, it will actually let me click on the very top and it tells me where it is. And what does this actually mean? Well, that's the vertex. The vertex is at 7, 2645000. 7, 2645000. Now what this gives me on the vertex tells me that this is our max revenue. Now notice that it is higher than our initial revenue, okay, which is what we wanted. We wanted it to go up. And what this tells me is that we must increase 7 times. Okay, so that means that n equals 7. So what price is it? Well, where was our price here? Our price started at $40, and we're going to increase it by $2.50 7 times. So we start at $40, price starts at $40, and we're going to increase it by $2.50 7 times. So what does that mean? Well, that means we got $40 plus 2.5 times 7, which means we need to sell tickets for $57.50. And what we were really looking for there was the vertex point, which we got from our graph. And oh, we've hit the 20-minute mark, almost 21 minutes. So sorry about that. We're going to call it quits right now.